necessary whenever business is trying to look into the future to develop an estimate of certain quantities or parameters that they might not know beforehand. So for example, for a certain product, if they want an idea to see where prices are going, and if they can get an estimate of this beforehand, it would help them to develop their contracting strategies accordingly and kind of hedge forward on prices. Then another use case would be where you're trying to predict what the demand for certain products might be, or the demand coming in across different channels might be. So you can plan your strategy across, say, e-commerce versus general trade or something. Then product recommendation is also not necessarily forecasting as such, but for a future time period, if we know certain variables that will impact customer behavior, like certain campaigns are running, or you're going to be targeting certain customers, what is the uplift that you expect? So these are some of the use cases where forecasting can really come in to help business get a better idea of where things are going.
Okay, so you mentioned product recommendation here. So is it like based on past user trends, you are kind of forecasting, for example, he started something about his marriage, like user's marriage, then maybe you will start recommendation something about, a couple products. And then, after a year or two or maybe more, you started recommending about the baby products as well. So is it that kind of time series involved here, or like, am I getting it wrong?
Yeah, definitely a time series element would be involved here, because a lot of parameters around customer behavior that we know will evolve over time. Like definitely with age, the kind of cosmetics that you use, for example, might really change year on year. Or even in terms of household products, the kind of products that you purchase would change based on which time of the year you're in or which stage of life you're in. So if we have those kind of that kind of information available, it can definitely be something through which we can make better product recommendations. But at times it's not necessarily just that. We can also get a fairly good estimate of how much of each product will be purchased based on also the historical patterns. There might be some element of seasonality involved where we know that we are going to see certain peaks. So we can use those as well.
Got it. That would be really nice. So I think it has a lot of implications and usage. So what are the different tools and algorithms that are involved for the time series forecasting?
So when we talk of forecasting, we can usually look at the traditional time series kind of route, which has its foundations in econometrics. That is where we try to look at a time series of anything, like say we're talking about product purchases or sales of a certain good. We break it down into its components like the trend, the seasonality, the cyclicity, and the general error component. And there a lot of assumptions come into play. So we try to look at whether or not a series is stationary, what kind of a model we can use, a time series model. And if we have additional variables that we might be able to throw in, for example, we might look at an array max model. And also there are a lot of other considerations there. Like for example, we need at least certain amount of history. So for a new product or something, we might not have enough history. So in situations like those, time series might not work very well. So the alternative to time series forecasting is where we can also use machine learning to develop forecasting models. So they are, I think, very different sides of the coin. And based on the situation, we can see which one to use. The advantage of traditional time series is that they are a little more interpretable, I would say, and you can actually try to break down the components of a forecast, whereas machine learning approaches might not give you that kind of interpretation. There are ways to get that interpretation, but these are two different approaches that we can follow.
Okay, so it's like one is pure statistics and second is machine learning based on the past data, right? Learning your own models. So in general, like statistics is the core part of having an ML model. It is always involved, like ML always involves some kind of statistics here or there. So aren't those two like interrelated?
Yes, they would be interrelated. But for example, when I'm building a time series model, it might be able to pick up the seasonality variable on its own. Whereas if I'm building a machine learning model, let's take a simple example. Let's say let's say I'm just looking at a linear regression. Now, what are the variables that I can use in this model? So if I want to use the seasonality component somewhere in the model, then that is a variable I will have to build myself. So something like a one hot encoded variable where for certain months of the year, I know that we will see some kind of seasonality. So those kind of features have to be engineered by yourself, especially if they are temporal features or time series features as we call them. Whereas the traditional time series packages would be able to infer these or build these on its own.
Okay, got it. So once you have made your time series model or anything, how do you evaluate that what are you doing is correct? Like, so you are currently predicting something that is not yet happened. So what's the evaluation metrics for that?
Yes, I think we're looking into the future, so definitely.
Yeah, yeah.
But there are
Huh.
different ways to understand how well the model would have performed if we had been using it. So the most, I think, popular approach that I have seen is called backtesting. So what we do is, say for example, right now we're in the month of September, and I've generated a forecast for October. I don't know how well it's going to perform, but I know which model I'm using. So what I can do is I can train my model up to a historical point of time, say April or May or something, and then generate forecast for the next month. And that forecast that I've generated, I can look at it and compare vis-a-vis the actuals to understand how well is the model doing, how biased are the predictions, and what is the range of error that I'm seeing. Is it we can do a kind of error decomposition to see whether it's specific to certain product or certain categories or certain segments of customers and so on, and look at the performance generally. And if we do this backtesting enough, say across 6 months or so of the past year, usually latest history is preferable, then that's a good way to showcase to the client that this is a model that would have worked if we had used it over this certain period of time.
Got it.
So usually a way to get an idea of how well the model would have worked. A few conditions there, of course, is the future should not be all that different from the past. So a model that I would have tested between, say, October of last year to February would not maybe perform in March or April given COVID. So there would be certain corrections we need to do there. But otherwise, everything, assuming that everything is stable, it's a good way to see how the model will work.
Yeah, I was thinking exactly the same. Like, so you're increasing your data, let's say by 3-4 months. So maybe user behavior changed a lot, and maybe during the testing it was working really fine, but at the time of productionizing, when you're training for the whole set of data till October, then it might picked up some different behavior that was not there earlier, and it might just not work as per the requirements.
Yeah. So to address that, there are also a few frameworks that are usually in place. So once a model goes into production, say, you also need to keep an eye on certain aspects of the model performance. So one would be, say, the hyperparameters of the model itself. Are they fairly stable over time? Are they changing a lot? And
Yeah.
forecast themselves. Are we seeing huge changes? You can look at the indices of the forecast to see versus month ago, year ago. Are you seeing huge numbers like 3 times, 4 times forecast? That and then generally overall the model performance. If you have a model with a certain accuracy score or certain a bias and standard deviation of each of the products, are those also stable over time, or are we seeing a lot of changes there? So generally a model health tracking also needs to be done maybe on a monthly or quarterly basis to see that what you have built continues to work.
Oh yeah, I think that's a pretty important thing to make sure that your model is consistent and it is not performing haywire or getting overfitted on extra data.
Yeah. And
Okay.
also if we are
Sorry, go on.
yeah, I just thought of one more thing, which is also the features that are going into the model. So usually along with the model predictions, business might ask for what are the drivers of the model. So if you're building something like feature importance plots to showcase which features might have certain impact, we also keep an eye on those to make sure that there's not a lot of shuffling going around in the features. Suddenly something becomes way more important. There might be a need to deep dive why this is happening.
That's true. Okay. So when you derive that this is going to be my predicted value, is there a particular parameter involved, like, to define the confidence in your result? Like, the answer will lie between plus minus 5% of prediction or plus minus 10%. Is there any parameter like that?
Yeah, so typically with whatever forecast we deliver, there's usually a discussion around point versus range forecast. So point forecast is a way of giving a single point of estimation, and usually for something like a price for which you're delivering a forecast, that might not go down too well with business because they want to work within some kind of range. So what we can do is look at the historical standard deviations, arrive at a confidence interval, and say that within this 95% confidence interval, this is where we see the prices going. So that way they get a range of prices to look at. And another way to do it could also be through simulating the inputs themselves. So for each of the features going into the model, you can see that if you expect them to range between value x1 and x2. So try to simulate the prediction of the model based on each of these combinations and see what the range might be. So that way you get not just one forecast, but a set of forecasts, and each forecast comes in from a range of the features themselves. There are two ways to look at it. Of course, there could be more approaches, but usually
Mhm.
giving a range might be a better approach.
Okay. And farther you go in the future, the wider the range would be, I would say.
Yeah, usually longer into the future, the further we go into the future, the less we expect our forecast would perform because the uncertainty just grows, which is why if you can give a kind of error estimate as well, that's a good
Mhm.
input.